And in this video, what we're going to do is we're going to talk about Bernoulli experiments. And so I just wanted to briefly bring up exactly what a Bernoulli experiment is. So a Bernoulli experiment, also known as a Bernoulli trial, is a random experiment that has exactly two possible outcomes, success and failure. The probability of success remains constant for each trial. This concept is fundamental in probability theory and is often used in scenarios such as coin flips or yes/no questions. Additionally, Bernoulli trials can be used to derive the Bernoulli distribution, which describes the probability of success in a given number of trials. So now that we have discussed the Bernoulli distribution or the Bernoulli experiment, then what we're going to do is we're going to go over some examples of the Bernoulli experiment in Python. And basically what we're doing is we're going to use the coursework in the Alison course, Probability and Combinatorics. And we're going to go over the questions that they had in the coursework. And we're going to solve these questions in Python. So the first question is, suppose the high school tennis team plays 10 matches in a season and the probability of its winning any one match is 3/5 or 0.6, that's 60%. We might be interested in knowing what is the probability that the team will win exactly 8 of its matches. So first thing that you're going to do is we're going to import the library SciPy, which is Python Scientific Library. So from scipy.stats, import binom. And then the given trials are going to be N, that's the total number of matches, is 10. P, that's the probability of winning, is 60%. And K, which is desired wins, is 8. So we're going to compute the binomial probability. So probability equals binom.pmath, that's probability mass function, brackets K and P. And then so we're going to print it out, and it's going to be 12%. So the next question we have is, suppose we assume that when rolling a die, 6 is success and all other outcomes are failures. The probability of success when rolling a fair die will be P equals 1/6, and of failure will be Q equals 1 minus 1/6, or 5/6. What is the probability of rolling 2 6s in 3 trials? So again, we're going to import SciPy. So from scipy.stats, we're going to import binom. And then the given values are the total matches is N equals 3. The probability of winning is P equals 1/6. And the desired wins, K equals 2. So we're going to compute the probability. Probability equals binom.pmath. That's probability mass function. K and P give you an answer of 0.0694. That's your probability. So now we have the next question. Is if the probability of failure is 1/3, find the probability of 6 failures in 10 trials. So your number of trials is N equals 10. Probability of failure is P equals 1/3. Desired failures is K equals 6. And then the probability, then we're going to use the binomial function in SciPy. So probability equals binom.pmath, K and P gives you a probability of 0.0569. The next question we have is, the probability of winning a game is 1/5. What is the probability of winning 2 games out of 4 if played? So the total number of games, so the first thing we're going to do is we're going to import scipy.stats, and we're going to import the binom function from that. But the total games is n equals 4. The probability of winning is p equals 1/5, and the desired wins is k equals 2. So we're going to compute the probability, and probability equals binom.pmf kmp. So the probability is 0.15359999. The next question we have is, a packet of candies has 2 different flavors. The probability of getting strawberry flavor is 60%. What is the probability of getting exactly 8 strawberry flavors out of 20 candies? So the first thing we're going to do is we're going to import scipy. So from scipy.stats, we're going to import binom. Total number of candies is n equals 20. Probability of getting a strawberry flavor is p equals 0.6. The desired number of strawberry candies is k equals 8. So we're going to compute the binomial probability as probability equals binom.pnf, and then brackets k and p. We're going to print the probability, which is 0.0355. So we have another question. Suppose a game consists of tossing a fair coin 7 times. To win, at least 4 of the coins must come out heads. The probability of getting at least 4 heads out of 7 tosses of a fair coin is given by, okay, and then this formula that we're going to give you is like if you were going to do it manually without the help of Python. So P, at least 4 heads, equals P 4 heads plus P 5 heads plus P 6 heads plus P 7 heads. But we're going to use Python. So Python's going to do all of that for us. So we're going to import scipy.stats as our scientific library. So from scipy.stats, import binom. And we're going to give in values is total tosses, n equals 7. Probability of heads, p equals 0.5. Minimum number of heads to win, k-min equals 4. So you're going to compute the probability of getting at least 4 heads is winning probability equals sum binom.pmf kmp for k in a range k-min brackets n plus 1. And then so the probability, we print the probability out, and it's going to be 50%. So the next question we have is, suppose a coin is weighted so that the probability of heads is 2/3 and the probability of tails is 1/3. What is the probability that in 5 tosses of this coin, the majority of the outcomes will be tails? So we're going to import scipy.stats, and we're going to import the binom function from scipy.stats. So the total tosses is n equals 5. Probability of getting tails is p equals 1/3. Minimum number of tails for majority, k-min equals 3. So we're going to compute the probability for at least 3 tails. So probability majority tails equals sum of brackets binom.pmf kmp for k in range k-min brackets n plus 1. And the probability, we print the probability, and it's 0.2099. The next question we have is, what is the probability that in a family of 5 children, at most one of the children will be a girl? This means that we could have 0 or 1 girl in the family. So the first thing that you're going to do is we're going to import scipy.stats, and from scipy.stats import binom. So the total number of children is n equals 5. The probability of each child being a girl is p equals 0.5. And at most, the desired at most 1 girl, Kmax equals 1. So compute the probability for at most one girl. So probability at most one girl equals sum, brackets, binomial PMF, K and P, for K in range Kmax plus 1. And then, so we print the probability, and it's going to be 0.1875. So the last question we have is, a game consists of tossing a coin 6 times. To win, at least 3 of the coins must come out heads. To find the probability of getting at least 3 heads. So the first thing that we're going to do is we're going to import scipy.stats. From scipy.stats, import binomial. And then we're going to define the variables. So the total losses is n equals c, 6, and total losses equals n equals 6. Probability of heads per toss is p equals 0.5, and minimum number of heads for winning, k-min equals 3. So we compute the probability of at least 3 heads. Probability at least 3 heads equals sum, brackets, binomial.pmf, k and p, for k in range k-min, comma, n plus 1, and we print that out, and the probability is 0.6562. So that's all the questions that we have in, I believe it was Module 9 of the Alison course, Probability and Combinatorics. And basically, what we're going to do in the next video is we're going to go over these questions in Excel. So you'll have an opportunity to use Excel to answer the questions as well. So the great thing about Python is you don't have to calculate these values manually, because when you calculate the values manually, it can be a little bit cumbersome, and Python takes the work out of it for you. All you have to do is the formulas. And when we get to Excel, Excel's going to be a little bit different, but again, it saves you the trouble of having to calculate those values yourself. So if you like my video, please like and subscribe. Thank you so much for watching my video, and I will be making another video for you very soon.